Good morning girls. We are discussing the chapter oscillations and today we will discuss about the simple pendulum. What is simple pendulum? First you see the figure. See here, this is a simple pendulum. That means when a bob is attached to the string and it is left freely, this system we call it as a simple pendulum. See here, see this point where the bob is tied, thread is tied, that point we call it as a point of suspension. If the length, here L is the length of the pendulum, from the point of suspension to the midpoint of the bob we call it as a length of the pendulum. So when we give a small amplitude, what happens if you move this bob and release, what happens? It moves to and fro motion. It takes the oscillation. It moves in the form of oscillations. So if it is moving, when we are giving a small amplitude, what happens here? The bob is moving to some distance making an angle theta. So here it is moving to some displacement y. So what is the displacement here? Here it is moving to the displacement OB which is equal to y, and also it is making an angle theta which is equal to here opposite by adjacent, that is y by L. This is equation 1. And also here the force which is acting on the string is nothing but the torque. Torque is the force which is acting on the string. So torque is equal to, we are having torque is equal to minus L mg sin theta. See here, mg sin theta is nothing but, here mg is the weight of the bob, mass of the bob, and g is the acceleration due to gravity. And it is in the opposite side, so it is, we are taking this restoring force in the terms of mg sin theta. It is coming back, bob is coming back with the help of the restoring force. So we are considering the L and mg sin theta. And actually the restoring force is nothing but tau is equal to I alpha. I is the moment of inertia, alpha is the angular acceleration. So here tau is equal to minus L mg sin theta and tau. Both are restoring force. So we can equate the right hand side, that is I alpha is equal to minus L mg sin theta. So here if we bring this I to this side, this equation will become alpha is equal to mgl by I theta. Hence if theta is very small, we can ignore the sin term. That means we can write in terms of sin, we can write only theta. So what is I here? Alpha is equal to mgl by, hence by comparing this angular acceleration with simple harmonic motion, we will get angular velocity is equal to root of mgl by I. So if substitute this value here in the time period, here what we have to find in the simple pendulum, with how much time the pendulum is taking to complete one oscillation. So to find out the time period, we are having the formula time period is equal to 2 pi by omega. Substitute the value of omega here, that is 2 pi by, in the place of I am writing this I by mgl. So I is nothing but, since angular moment of inertia is equal to ml square. So write down the moment of inertia value here, 2 pi. So substituting this I value here, ml square by mgl, L and square gets cancelled and mm gets cancelled. What are the remaining terms? 2 pi by root of L by g is nothing but the time period to complete one oscillation.